All right, so now we're going to keep extending the idea of polynomials here in assignment number 3. We're going to look specifically at the zeros of polynomial functions and how those zeros can be used to help us sketch a graph of those polynomial functions, and then also how we can go from the zeros to actually write equations. So let's go ahead and get started. So with this first example, right now we have a polynomial that is in standard form. And what we're going to do is just write this polynomial in factored form. So let's go ahead and do that first. I'm going to go ahead and factor out a 2 and an x because a 2x goes in both of those. 2x times x squared gives me 2x to the third. 2x times negative 7x gives me negative 14x squared. And 2x times 10 gives me 20x. So now I'm going to go ahead and factor this factor. So I have x times x gives me x squared, and if I multiply negative 5 times negative 2, that gives me positive 10, but negative 5x and a negative 2x gives me negative 7x. And so in factored form, we have 2x times x minus 5 times x minus 2. And so then we want to, it says when is the function equal to 0? Well, if this was equal to 0, there would be 3 places where it could be equal to 0. We have 3 factors, this one, and this one, which if either one of those, any one of those factors were equal to 0, then the whole thing would be 0. So that means either 2x, if 2x was 0, this whole thing would be 0. If x minus 5 was 0, the whole thing would be 0. And if x minus 2 is 0, the whole thing would be 0. So there are actually 3 zeros. If I solve all 3 of these equations, if I solve this one first, I'll have x equals 0. If I solve this one next, I'll add 5 to both sides, and x will equal 5. And if I add 2 to both sides, I'll have x equals 2. And so those are called the zeros of the function because it's when it gives you a total value, an output value of 0. So then what we want to do is plot these points on a graph and try to sketch the rest of the graph. And I'm going to go ahead and do that up here. Here we have a graph, and this is going to be one of the main ideas for today. It doesn't really matter how far up or down low this graph goes, but what I want everybody to understand first is that along the x-axis, here's the x-axis, that's when y is equal to 0. Okay? So if I had y equals this function, when y would be equal to 0 is at 3 places. If I plug a 0 in here for these x's, I would get a y of 0. So there's a point at 0, 0. If I plug a 5 in for these x's, if this was a 5 or this one was all these x's were 5s, then the y would be 0. Well, that's the point 1, 2, 3, 4. The x is 5, the y is 0. And then if I let x be 2 and plug a 2 in for these x's, I would get another 0 back out. So my zeros look like that. And so I don't really know much about the graph at this point, but I do know it hits the x-axis in those 3 places. And so the other thing that I do know is that it's going to change from positive to negative somewhere in these intervals. It's going to cross the x-axis in these 3 locations, which either means it's going to do something like this and cross it here and end up going up high like this, or if I do this in green, let's say it's going to do something like this, where it's going to come down and cross here and then go down forever. And so how do we determine whether it's the red one or the green one? Well, that's something that we're going to go on and talk more about here in a little bit. But one of the shortcuts here is this. Let's say that I look at specifically this interval here from 0 to 2. And I plug in a number right in that interval. Let's just say I plug in a 1. If I plug in a 1 into the factors, if I plug a 1 in here, that's going to be 2 times 1, which is going to give me a positive number. This is going to be 1 minus 5, which is going to give me a negative number. This is going to be 1 minus 2, which is going to give me a negative number. So I'm going to have a positive times a negative times a negative. Well, 2 negatives make a positive, and a positive times a positive is going to be a positive, which means when I plug in a 1, it's going to be a positive value back out, which means it's going to be this, looks like it's going to be the red area. If I were to plug in, let's say, a 3 or a 4, I would get something that's negative, which would look like this. And And then if I plug in something above a 5, like a 6, I'm going to get something that's positive. And so we know it's going to look something like this. Another thing that we can do is this, is when the biggest effect is going to be the leading term. So when I cube something, if I plug in 100, the 100 cubed is going to be a lot bigger than 100 squared, which is going to be a lot bigger than 100. So this is going to have the biggest impact on the graph. And so when I plug in a very big number, like 100 cubed times 200, that's going to be a positive number. And if the leading term is going to be positive, then I know as I go way over here to the right, it's going to be a positive value. And so I know the graph is going to look something like this. Let's go ahead and take a look at a different situation. So now we're going to work backwards. What we have here is 3 zeros, and we want to write the equation. Well, if I have 3 zeros, that means I should know 3 factors. I'm kind of working backwards from before. I know that if 1 is a 0, x minus 1 has to be a factor. If 3 is a 0, x minus 3 has to be a factor. And if negative 2 is a 0, then x plus 2 has to be a factor. And so those are the zeros. That means that these 3 factors, if either one of these are 0, I'm going to have a 0 for my y value. So it's going to look something like this. I'm going to call that y for right now. And what I want to do is put this, right now it's in factored form. And what I want to do is write this in standard form. So I'm going to have to FOIL here. I'm going to multiply these two together first. I'll have x times x is x squared. X times negative 3 is negative 3x. Then negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. That would simplify to x squared minus 4x plus 3. Well, then I'm going to multiply that times my other factor, which is x plus 2. So again, I'm going to FOIL here. X squared times x is x to the third. X squared times 2 is 2x squared. Then I'm going to multiply my negative 4x out. Negative 4x times x is negative 4x squared. Negative 4x times 2 is negative 8x. 3 times x is 3x. And 3 times 2 is 6. So my final answer is going to look something like this. I'm going to have my leading term is just x to the third. 2x squared minus 4x squared is minus 2x squared. Negative 8x plus 3x is negative 5x plus 6. And so this is a polynomial in standard form that I could factor to look like this. Once I had this, I would know my zeros are going to be 1, 3, and 2. Let's take a look at a different example. We want to factor the following polynomial. And so let's go ahead and start by factoring out the greatest common factor here. Something that goes into 12, 36, and 27. Looks like maybe 3 would be the biggest number. And I can also pull out an x to the fourth. And so 3 times 4 gives me 12, and x to the fourth times x squared gives me x to the second. 3 times negative 12 gives me negative 36, and x to the fourth times x gives me x to the fifth. 3 times 9 gives me 27, and I already have my x to the fourth. Then I wonder if I can factor this again. I have the 3x to the fourth, and now I'm going to try to factor this again. Suppose I have 2x and 2x. That gives me 4x squared. And I'm going to go with a negative 3 and a negative 3. Because negative 3 times negative 3 is positive 9. But this is negative 6x and a negative 6x, which gives me negative 12x. Well, I'm going to write this then like this. We have 3x to the fourth. And then we also have this 2x minus 3 to the second. This is what this looks like in factored form. And so, what are the zeros of the function? Well, the zeros are when those two things equal 0, which means if this is equal to 0, I could have 3x to the fourth equal 0, or I could just say this is 3x times 3x times 3x times 3x, which means if one of them is equal to 0, they're all equal to 0, and it's going to be equal to 0 when 3x equals 0. If I divide by 3, x is 0, which means one of my zeros is just 0. The other 0 is when 2x minus 3 is equal to 0. Now I could have two of them there because it's squared, But if 2x minus 3 is equal to 0, then I would add 3. So 2x equals 3. And if I divide by 2, x equals 3 halves, or 1.5. So those are my two zeros. Now, we're going to talk real quickly about multiplicities. 0 is a 0 of the function, and it shows up 4 times. So the 0 has a multiplicity of 4. The 1.5 has a multiplicity of 2 because it shows up 2 times. And so most of the time when we find a 0, it's going to have a multiplicity of 1. But if it shows up more than 1 time, we say it has a multiplicity of 2 or 3 or 4. So now when we sketch this equation, we know we're going to have zeros at 0 and at 1.5, which is here. However, they're not going to cross at those points. They're going to bounce at those points. And here's why. Like, for example, if I were to graph y equals x squared, we know that that is a parabola that looks like this. It hits and has a 0 at 0, but it doesn't change from a negative to a positive. It comes from a positive and goes back up to a positive. That's because when I plug in negative numbers or positive numbers, it always ends up being positive. That's always going to be the case when the multiplicity is even. And so we say that it doesn't cross there, it just bounces and goes back in the same direction. So that's what's going to happen here. It's going to come down and bounce here, and it's going to bounce here. And it's going to look like a graph that hits the x-axis in 2 locations, but it's not going to cross the x-axis in either one of those locations. It could also do this. It could come from down below and bounce and hit it twice and go back down. However, when x gets really big, we just talked about this, that when x is really big, we know it's going to be positive. So the end behavior is going to be that it's going up. Let's practice these graphs a little bit further when we look at number 4 and 5. Number 4 is going to have a 0 at 3, which is here, and a 0 at 4, which is here. The 0 at 3 has a multiplicity of 2, so it's going to bounce here. And the 1 at 4 has a multiplicity of 1, so it's going to go through the graph here. When I multiply these together, I'm going to have an x squared here times an x, which means the leading term is going to be positive, which means it has to be going off on the right in a positive direction. Now it's going to go through here, bounce here, and go down in this direction. So number 4 is going to have a graph that looks something like this. Number 5's graph is going to be a little bit different because it's going to have a 0 at -2, that's this one. It's going to have a 0 at 1, which is this one, and it's going to have a 0 at 5, which is this one. But each one of these has a multiplicity of 1. And if I just look at the leading term, I'm going to have x times x times x, which is going to be y equals a positive x to the third, which means at the very end of the graph, it's going to be going up. Well, if it crosses at each of those 3 points, that means it has to go down here. It's going to cross, and it's going to cross again, and the graph is going to look something like that. I don't really know how far it goes up or how far it goes down, and at this point, I really don't care. I just want to get a good sketch for the graph, which means finding the correct zeros and then determining whether it goes up or down at those locations. This is going to be something we're going to talk more about in class, but finding the zeros, putting it in factored form and finding the zeros and actually going from the zeros to factored form and then getting an idea of what the graph looks like is going to be important for what we're going to be doing for tonight. So we will talk more about this in class, and good luck on your homework assignment. We will see you tomorrow.